So you might have seen an article like this one here in the BBC recently, where they say we've discovered the closest black hole to the Earth. And this article goes on to say that this black hole should be about 1,000 light years away from us in a triple star system, known lovingly as HR 6819. But this article kind of glosses over a lot of details, and one of those details is that this is still being debated. So let's go through some of the actual papers that are published on the subject and see what the debate is. So let's skip past this article now and go to the paper itself, which announced the discovery. So there's a few key takeaways from this paper, one being that this black hole, or a supposed black hole, is discovered in a triple system, or at least they say it's in a triple system. And the reason this system was studied in the first place is because it contains a very strange star, a BE star. And this BE star is an extremely rapidly rotating star. It's rotating so quickly that it's almost tearing itself to pieces, which is really strange and well worth investigating. But along the way of trying to investigate this star, they came across some evidence, or at least they suspect evidence, for the presence of a black hole. And this black hole would be around about 5 times the mass of the Sun. So how did they come to this conclusion? Well, they looked at the star system and they took spectra of it. So they split the light coming from the star system up into a rainbow and looked at how that rainbow had bright patches and fainter patches, which indicate the presence of atoms. Now, if this BE star, which is rapidly rotating, is by itself, you should just see very broad features in the spectra, because the rapidly rotating star means that there's lots of Doppler shifting going on. So the Doppler effect comes in for light, so parts of the star that are moving away from us will redshift the light, parts of the star that are coming towards us will blue shift the light. So that means that all spectral emission lines and absorption lines should be spread out due to the rotation of the star. But interestingly, in this little introduction here, they say that a while ago it was discovered that there are a few narrow lines in the spectra, and this wouldn't fit a BE star, which means that there must be another star in this system. So they look at all of these spectral lines and they do some math to work out what's going on. And in particular, they look at this companion star to the BE star, or a supposed companion, and plot its radial velocity. So I mentioned the Doppler shift before, and that's due to the speed of something's motion. So as well as the Doppler shift coming into effect from a star itself rotating, the Doppler shift can come into effect from the entire star moving. So if it moves away from us, it is red shifted. If it moves towards us, it is blue shifted. And this happens for all of the light that the star emits. So if you look at how the light behaves in these narrow emission lines and absorption lines, you see something like this, where the object appears to be moving on order of up to 50 kilometers per second, which is pretty quick. But this is strange, or at least these people publishing this paper think it's strange, because they don't see any evidence of the BE star, which was the original one they wanted to look at, moving in an opposite way. So if they were a binary companion, you would expect to see the BE star to have the exact opposite curve. So it would be low when the B star is high and be high when the B star is low. Because if they're orbiting around each other, the velocities must be opposite. So let's look at one of their pretty interesting diagrams here, which show us what they were looking at. You can see this kind of snake in these spectral line features. The snake shape is what's telling us that there is some motion going on with this interesting companion star. So they use this information along with information saying that this emission line here, this H alpha emission line coming from a hydrogen atom, there doesn't seem to be a similar wiggle. They say that this is evidence that the BE star isn't part of this binary motion, that there must be something else causing this B star to wiggle. And they say since we can't see any light coming from this other object making this star here wiggle, it mustn't emit light, therefore it is probably a black hole, which seems like reasonable thinking. And that's pretty much the summary of this paper, because it's a short letter. They say that it's a triple star system and that it's likely that one of those objects is a black hole. Now, if you're me and you're scrolling through Twitter and it's bombarded with lots of astronomy news, you'll find this really interesting post from Kareem, where he talks about a paper that he just published along with some collaborators, which refutes this claim that there's a black hole in the system. So again, let's look at this paper. So the main difference here is that they do something different with the spectra. They say, alright, there is a binary star system here. If you take observations of the light coming from this, all of the light will kind of be mixed together. So instead of just saying we'll look at the narrow line emission or absorption and say it's from the B star, we'll use some very fancy analysis methods in mathematics to disentangle, break apart the spectra. So you can separate it into the B star spectra and the BE star spectra. So notice here that the absorption lines of the B star are much sharper than the BE star. And that comes down to what I was saying earlier, that this BE star is rapidly rotating. So that's a cool bit of evidence for this speed of the rotation. So now that they've separated these two stellar spectra through their analysis methods, with some assumptions along the way, they're able to perform the same kind of analysis, and they find that the BE star is moving in the opposite direction to what the B star is. So here's the B star motion, like what we saw before, and here's the BE star motion, which is what the other group said didn't exist. They didn't find any evidence for the BE star. But using this disentangling method of the spectra, this group was able to, or at least claims that they're able to find evidence of BE star moving. So again, they do it through those absorption and emission lines to find that there is a small velocity. And they find some things that say that this is just a binary star system where you have a BE star orbiting another star, and they come to some very interesting conclusions about the nature of these stars as well. One of the stars, the B star, would have puffed up earlier in its life, and the BE star supposedly stole all of the material away from the B star, making it much smaller and the BE star much bigger. And this paper isn't the only one to refute the claim that there's a triple system with a black hole as part of it. The other paper, which we'll look at here, is also saying the same thing as the one we just looked at. They do a similar spectroscopic decomposition analysis and analyze the spectra and find pretty much the exact same thing with some assumptions as well. In this case, their assumption is that you only have two stars in the system, so you can say that if one has a 40-day period in its orbit, the other one should also have a 40-day period in its orbit, which seems like a pretty reasonable assumption. And through that analysis, they come to the same kind of conclusion, that this is just a binary star system. So going back to this article here, you might have seen things like this in the media talking about the, I guess, sensational, exciting explanation or discovery that we've found a black hole close to the Earth. But in reality, these things are really challenging and can be contested at any time. No claim in science is foolproof. You can always find more evidence that might disprove what you claim. And in this case, it'll be interesting to see if these places like BBC publish follow-up articles to say that we have not, in fact, found a black hole around a nearby star, if that proves to be the case. But anyway, this was, I think, an interesting insight into the process of science. It isn't clear, cut and dry, and sometimes the media can muddle things up and make things seem certain when they're still under discussion. So anyway, that's it for this time. Thanks for watching.